Welcome to this edition of our detailing challenge. In the last edition, we were able to demonstrate how you can start your detailing from scratch. In today's edition and subsequent videos, we'll only be applying what we have done in the previous videos. So I encourage you to watch the other videos as we continue, because some of the steps I'm going to be skipping in this edition. Today we are going to be looking at panel 2 and panel 3. We are picking 2 and 3 because they have similar configuration. Panel 2 and panel 3, the dimensions are 5 meters by 6 meters. So let's go on and check our design companion. We'll copy what you have done, the first step, and then insert. So this becomes our 2, and then panel here, panel 2, and panel 3. So let's look at the end condition. The end conditions, the shorter edge, we say discontinuous. Okay, let's look at it again. These edges, discontinuous. For a two-way slab, you are always concerned with design of the panel. Then bearing in mind the edges, the conditions of the edges, are they continuous? Are they discontinuous? So in this case, the shorter edges, continuous. See, continuous. Our LX, our LS is discontinuous in both directions. Right now, I will not pay attention to this. This is something we can edit much later. Then we have P3. Okay, so we come here and we put our information, the general information, which is 5 meters, the LS, and the LY, which is the longer span, is 6 meters. So the other parameters are the same from the previous edition. So let us continue. Then the number of continuous edge, short span, is what? Is 0. Long span, the continuous edge, we are dealing with the edges now, is 2. So meaning the slab is continuous over 2 long edges. Then 2 short edges discontinuous. So when we put that, we have our loading information. Please, all these have been explained in our previous videos, and I will advise you, I will encourage you to visit those videos for better understanding. So now we have this. So let's see. Our reinforcement requirement is 291. So we are going to be supplying Y10 at 200. Then the continuous edge, what do we need? We need 398. So in this case, we are assuming bar 12, and then let's see, we'll do the 200. So Y12 at 200. Then the same way, we also have about the required reinforcement 243. So in this case, that's the long span. The reinforcement required is Y10 at 200. Similarly, we go to others, check the deflection, which is okay. So from what we have here, apart from the a continuous edge for short span. Apart from that, which is Y12 at 200, others are Y10 at 200. So let's go back. So all we need to do, of course, we want to delete dimension lines. When we are detailing, we focus on the reinforcement and not the dimension. Okay, so in this case now, what we are saying is that this is our short span. So the reinforcement in this direction is going to be Y10 at Y10 at 200. So we draw this, right? But since both are similar, we are going to extend it. So this becomes our reinforcement for the short span, which we start from this grid E to grid C, or vice versa, whichever way you want to put it. So all we need to do here is just to extend this by 300, then, and this is to enable us have proper lapping. Then extend this by 300. So, but we have to check that the entire span is not more than 12 meters, and this is 10.6 meters. So we are good to go. The next thing we will do is to copy this, indicate our span. Don't need to start all over, so we have to copy what we already have and place it wherever we feel is that there is space. So we are going to move this here, copy here to indicate the direction of the reinforcement. The spanning of the reinforcement is spanning from this point. We're distributing this from this point to this point. So take this, so we have this, and then the next thing we'll do is to copy this to any available space. Come here, and then we extend this. Extend this to this point to just show that this reinforcement, this is where we are calling it out. The next thing we'll check is to check what this width is, what the dimension from here is, and then we have it 5725. So 5725 divided by 200. Remember, from our calculations, we say y10 at 200. So if we approximate this will be 29 plus 1, which is 30. So this is going to be approximately 30 bars. So come here and use 30. For this span of up to 5 meters, I usually limit my reinforcement to Y12. And this is just to err on the side of safety, just to take extra caution. And that is why, even though based on the analysis, Y10 at 200 was okay, but looking at based on experience and looking at the span of up to 5 meters, I rather want to use Y12. So that means we are done with this. The next one we are going to do is to uh, do that the reinforcement for your longer span. So we take this, just extend this down. Don't need to start from the scratch like I said earlier. Already working with what we have drawn. So we have it as 25. Then this is it. So the next thing we are going to check is to check our 0.5 length, 0.15 of the length. Let's see, 0.15 times the length. So if we do 6,000, this is 900. Just to avoid confusion, just to make my drawings consistent, and whosoever is placing this reinforcement on site, it will be easier, there won't be confusion. And that's because the continuous support based on code is supposed to be 0.25 L, but in this case I'm going to be applying the same for the discontinuous edges, even though if you do the 0.15 times the length is still okay. So this will give me 1.5. You have to check. Okay, we say from here. So we want to extend this, the extension 1,500. So when you check 1,500, when you check the entire length of this return from the support, you have this. So it's okay to make this 1,600. 1,600. So let's go on. Meaning our bar is 1,600. We extend this also to give us 1,600. So the next thing is the spanning is to copy this. I'm going to copy this. It's okay. From here, we have this. I'm going to copy this. Say we have this. Copy this. Just place it anywhere and then you adjust it. Come here. Spanning from this point to this point. And take this to the end. We are taking it to the end because the edge conditions from this point to this point is the same. So we want to copy another one. We can equally copy whatever we have done before and copy it to okay. We have this, we have this, and this. So the next thing we are going to check is what the length is. 4725. 4725 divided by 200, which you have as approximately 24, plus 1, it will give us 25. 25. Okay, so since we have whatever is happening here is what is happening here, We are going to extend this. We'll copy this, either copy or mirror. Copy it and then adjust it. So we are saying this is equally extending to the end. Invariably, what we are saying is that this reinforcement at the site, when you bend this reinforcement, you are going to start from the beginning all through to this point. From here, spanning from here, the same reinforcement. You take it from this edge, this is a start up to this point. So 25 plus 25 will give us 50. Even though it's Y10 at 200 based on the design, I'll still, for similar reason, I'm still going to make it Y12 at 200. Right now, I will not bother myself with the bar mark, and that is the importance of using this method, this format. So because when I'm done, it will be very easy for me to change the bar mark. So from here, what it means is that for these two panels, I am done with the bottom reinforcement. So the next thing we are going to do is to move to the next panel, in which we have 5.5 meters. Then we have 6 meters, 5.5 meters by 6 meters, meaning this short edge is continuous on this side, but discontinuous on this side. But the longer edges or the long edges are continuous on both ends. So the next thing we do is to detail design panel, the panel 4. So I'm going to copy this again. I'm not overriding what I've done before. I'm copying because this may be required for generating our design report. So here we're going to look at P4. And then here, this will be 5.5 meters and the 6 meters remain. Please, whatever we have done before, the edges, I'm going to ignore all this for now, just to save time. So whatever we've put here before is still the same. So the only thing we're going to change is the condition. The number of continuous edge, the short edges, 1 is continuous. The number of continuous edge, the long span, 2 is discontinuous. So the load case here is load case 2. The slab is continuous over 3 supports, 1 short edge discontinuous. And then we are good to go. From here, still 10y, 10y, y10 at 200 is this sufficient? Then we scroll down, y10 at 200 is also sufficient. Continue like that. Y10 at 200 is sufficient. And then here, the deflection is satisfied. So we'll go back. What we'll do is to implement what you have designed. So start from here. And then let's say we'll get to this end. But let's confirm, this is more than 12 meters. So we have to shorten it to this point. And then we check. This is 10 meters, which is okay. So the next thing, we extend this by 300 as usual. And we extend this by 300. So the next thing we'll do is to, okay. So with this, we'll still do similar thing again by copying from this location to any location to this point, wherever there is space. Okay, we are still having the same number of bars, so I don't need to change this again. But you see, we are already moving further away from the left hand side. So all I need to do is to mirror this and mirror this. Take this to just adjust it a bit. Okay. Now, whenever I mirror what is here from the left, I want to justify this to my right. I'm going to explain. For instance, if I'm changing, let's say this is 300, you see that my B here will be encroaching with the bar mark. So all I need to do is to change this justification, that's justify, to my right. So, and then move this, because the moment I'm changing this, you see, it's moving to my left. I will adjust this, just adjust it in order not to, clash with this grid knot. So extend this, and then adjust this. So the next one will be my reinforcement for the longer span. So I'll still copy this from here to here, but I don't want it to be on the same line, so I'm going to adjust this. Also, this is already clashing. I'll adjust this, and then, but the edge here is continuous. So because of that, you can easily extend this, right? Then you can take this, okay. Let me see. Let me trim this off, and then extend this up to this point. Because it's bottom reinforcement, and for a cantilever slab, bottom reinforcement is more or less a nominal reinforcement. So whatever I have here, for sake of ease of placement, I'm still going to extend this, so I don't need to start with a new bar since it's still within. Anyway, we can check. The length, the total length, and check it by checking here, which is less than 12 meters. So the next thing I'll do is to copy this, and it doesn't matter the sequence you want to follow. doesn't matter. So what is most important is you understanding the concept and why is it done the way it is done, so that you can also apply your own style to the detailing. So I'm going to copy this, and measure this to see. This is 5225. So 5225 divided by 200 is going to give me 26 plus 1, which is 27. So changes to 27. Then this, looking at the configuration, we still have this discontinuous side is still spanning up to this point. So we can still copy this to this point, copy from here to here, and then this can go from this point to this point. See? Then we'll take this here. This is because the same bar can still work for this edge and this edge all the way to this point. So you don't need to start a new bar, except where your reinforcement requirement for this panel is different from this panel. And what I mean is that, assuming what you calculated for this is Y12 at, let's say, 100, and here you need only Y10 at 200. For sake of economy, you might not want to use the same bar. But in this scenario, the requirement is the same. Whatever reinforcement we're having here from calculation is still the same for this. And that is why we are using the same bar. We are going to measure it and check how many bars we are going to have spanning from here to here. So we have 2225 So we have 2225 divided by 200, and this is 11 plus 1, which is 12. So by the time we add 27 plus 12, what we are going to have, 27 plus 12 will give us 39. So meaning the total bars we are going to have here is 39. That's 39 Y12 at 200. So the next thing, because we still have the same bar, because we still have the remaining portion to detail, we'll now still copy this bar to this point, and then we can, since this portion is continuous, we can remove this continuous, remove the return, and then we extend this, let's say to this point, and then we'll go by 300. I could have extended it down, but I have not checked this, and also from here to here is more than 12 meters. So I have to limit the length of my bars, of the bar. So when I take this here, and this configuration at this point, at the edge here, is still similar to whatever I have in this panel. So because of that, I'm still going to take this, copy this, to say okay, I can copy from here to here, right? But I'm going to take this down. You can equally copy it and adjust it later. Take this either up or down to the available space. Sorry. Copy this. To the next available space, and then I'll delete this. Delete and trim this. So let me adjust this from here to here. So the next thing, take this. Like I said, the sequence doesn't really matter. What matters is understanding how this is done fundamentally. And with that, you can add your style. But whatever style you're adding has to be acceptable. So I'm going to, this is 1757. So 1757 divided by 200. So to give me 9 plus 1. 9 plus 1, which is 10. 9 plus 1, which is 10. And then you have 4725. 4725 divided by 200. This is approximately 24. Then plus 1 to be 25. 25. So 10 plus 10, 25 will give us 35. So what it means is that these bars, the number of bars here will be 35 at Y10, at Y12 at 200. I've explained why I'm using Y12, but based on analysis, Y10 is sufficient. So don't forget to include hash. Okay, you have to tie it. So from here, what it means is that the entire portion or the bottom reinforcement for this has been taken care of, right? But except for this. So in this case, I will go here for this one. I'll go here, draw this to this point. I can extend this since it's bottom reinforcement. I don't need to worry myself so much until, because the main reinforcement here is a top reinforcement, and right now we are still dealing with the bottom reinforcement. So this is 300. Okay, so whatever I have here will still work for me. So I'm going to copy this from this point to this point. So I can use the next space, available space, to say okay, this here. Adjust this space anytime, move it up and down whenever you need to make space for another one. So we have this, mind you, this reinforcement, just this a little. This is continuous here, and because this edge is what is extended at this point, we will not be able to do what? Use the same bar. However, you can take it down and copy it here, right? Or let's take a similar bar, because we'll look for the similar bar and then we'll copy the similar bar, just copy, and then we adjust. Instead of starting from the scratch, we adjust that, see? And we'll take this, kiss it to the end, and take off, take off the cover. Okay, so the next thing we'll check what the span is direction 7,000, meaning 7,000 multiplied by 0.25, which is L over 4, 1,750. So as usual, 1,750. Take 1,750 from here. 1,750. What do we have? 1,8. So if you can choose to do 1,900 or even 2,000, right? And this takes care of so many things which we discover later. So the next thing is to what? Is to copy. Just for me to copy this here. This is spanning from here to here, right? And then you can equally mirror this, right? Then we can adjust this a little. Copy this to the space here, and either do this, match, okay, then we'll trim. The next thing is to take this here, put this from here, so adjust, So what do you have? This is 1,950. So we have 1,950 divided by 200. This will give us 10 plus 1, 11. 11. We have 11. And in this case, I can use 10. Looking at the portion, and then it's not so critical, or let's leave it as 12. So this is what we have. You can see I'm not jumping into extending it to this panel, because by observing this panel, you will see that this panel is much longer, small. Let's see. The area of this panel is small. So we have 7 meters by 7 meters. So we have to visit our TracForth slab companion, and then what do? We go back. Okay, let's go back to copy this. Copy. And we have number 4, panel P5, P5. So we are going to take this as our P5. It's our P5 because 4, 1, 2, 3, 4 has been able to generate this. So we'll consider this as our P5. So let's go on. The edge conditions, because this continuous side is more or less more than 70%, we are going to consider this as continuous. Then this also is continuous, continuous, continuous. So this span is continuous at all the 4 edges. So we have this as 7 meters. We have it as 7 meters. So all this there. So let's see the edge, number of continuous edge 2. So this is an interior, a typical case of an interior slab panel. The slab is continuous over all the 4 supports. Okay, let's go on. So we have this. In this case, reinforcement required is 336, right? Let's see. Reinforcement required. So this is still okay. Let's check. Reinforcement required. This is still okay. Right? Reinforcement required. This is still okay. However, by the time we get to check for deflection, its serviceability limit state, you discover that the deflection is not desirable. The deflection, you can see, the deflection is the actual deflection is above the allowable deflection, which is the determined here or checked here by our span to depth ratio. So the actual span to depth ratio is more than what is provided. And there are many ways of handling this. The first is either to increase the section, or we can adjust the bar. But I doubt if the bar will satisfy this here because of the difference. But assuming you have this as, let's say, 43 or 42, maybe adjusting the bars may work. Watch out for the next episode where we shall continue with our detailing challenge.